this is R represents the magnitude of the given vector, and cos beta we will get it as y divided by r. A vector whose initial and terminal point coincide is called zero vector or null vector. The vector and its negative of vector A, then the resultant is always vector 0, which is a null vector or the identity to the vector addition. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are moving with the new chapter, Vector Algebra. So in today's session, we are going to learn the basic concepts related to the vector. So we know that a scalar quantity as well as vector quantity, which you have studied in your physics. A scalar is nothing but which has only magnitude, and vector is a quantity which has both magnitude and direction. When it comes to mathematics, vector has a certain value, that is the magnitude, and usually we call that magnitude as the length of the vector. Then what is a vector? Here, a quantity that has magnitude as well as direction is called as a vector. So here I have taken a vector AB. So the line which starts from the point A. So point A is called as the initial point of the vector. So this is called as the initial point of the vector. And the vector where it stops at the given point. So this is called as the terminal point. So this is called as the terminal point. So usually we will denote the vector in the form of vector A, vector B, vector C, like that. If a line segment has taken, then we write the vector in the form of vector AB. So AB vector denotes that its initial point is vector A and whose terminal point is vector B. Suppose I write BA, then whose initial point will be B and whose terminal point will be A. Then the arrow mark will shift this side. Okay. So it is a vector from A to B. When I say B to A, B will be the initial point and A will be the terminal point. So these are the symbols we use to denote the vectors. Now coming to the magnitude of the vector, I said magnitude is nothing but the length of the vector. So we have initial point as well as the terminal point B. Okay. So the distance between this is nothing but the length of the vector, which is nothing but the magnitude of the vector. So usually the magnitude of the vector is written in terms of modulus because distance or length is always positive. So therefore, even though the direction changes towards the positive or negative when we consider it in a coordinate system, the distance of the vector is always taken as positive. That is why we take it as a modulus of the given vector. Next we have position vector. What does this position vector mean? So position vector means here we are taking the vector in coordinate system and we are finding the distance of the vector from the origin. So now here we have a vector. So this is point P whose terminal point is point P. So we draw a line from the center O. Then it becomes a vector in the direction that is OP. So here we have vector OP, which I have taken as R. So now to find the magnitude of this vector, we can apply the distance formula. Magnitude is nothing but the length of the vector. Since we have 2 points here, we can use the distance formula to find the length of the vector. So how we will use? We can write it as magnitude of R, or I can also write as magnitude of OP, vector OP, which can be written as, if you apply the distance formula, it is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square under the square root. So therefore, the magnitude of any vector can be taken as x square plus y square plus z square whenever we have the position vector from the origin, that is OP. So vector OP distance is nothing but the square root of x square plus y square plus z square. Next we have the direction cosines. What is this direction cosines? So here I have taken a position vector here. So which is taken as vector u here. Okay. So here, what are the angles made by this? What are the angles made by this is called as, that is, so the angle made by the line with the x-axis. Okay. So this is one angle, and angle made by the y-axis with this line. This is another angle, and angle made by the line, that is with the z-axis, is another angle which we can take as angle C here. But in general, angle made by the three axes with the line is taken as alpha, beta and gamma in general. And these are called as direction angle. Cosine of these angles, okay, that is cos alpha, cos beta and cos gamma here, gives you the direction cosines of the given vector. So there is another general denote to this angles, that is L is nothing but cos alpha, M is nothing but cos beta and N is nothing but cos gamma. So these are the other denotions to write the direction cosines. Now when I say here, the distance can be taken as, that is the distance of a line from x-axis. So this is the distance. So this is parallel to this line, which I can take it as A. And the distance to y-axis is parallel to this line. So whose coordinate system is y, that can be taken as B. And this distance here can be taken as C, since it is parallel to the z-axis. So if you apply cos of alpha, beta, gamma, we will get here cos alpha as x by r. So this is r represents the magnitude of the given vector, and cos beta we will get it as y divided by r, and cos gamma we get it as z by r, where x, y, z denotes the coordinate points in the three-dimensional axis and r denotes the magnitude of the position vector given. So I can write the cos alpha in the form of L is equal to x by r, and M is equal to y by r, and N is equal to z by r. So now here you can see, let me see what is L square plus M square plus N square here. So L square is nothing but x square by r square, M square is nothing but y square by r square, and N square is nothing but z square by r square. We know that the magnitude of the vector r, simply we denote it r, or we will write this like this. So magnitude can also be denoted as simply r. So this is square root of x square plus y square plus z square. So if I need r square here, this is nothing but x square plus y square plus z square. So now by adding this, we will get x square plus y square plus z square divided by r square. So r square here. So what is this x square plus y square plus z square? It is r square. So it get cancels. The value is equal to 1. So therefore, the sum of squares of the direction cosines of the position vector is equal to 1. So that is L square plus M square plus N square is equal to 1. Or we can also write cos square alpha plus cos square beta plus cos square gamma is equal to 1. Next, types of vectors. So what are the types of vectors here? So zero vector. We know that a vector is a quantity which has both magnitude and direction. Again here magnitude represents the length of the vector. So a vector whose initial and terminal point coincide is called zero vector or null vector, and it is denoted by vector 0. So that means whose length is 0. The vector whose length is 0, or which means both initial and terminal point coincide with each other. So therefore it is called as zero vector or null vector, and it is denoted using the symbol vector 0. Next, unit vector. A vector whose magnitude is unity or 1 unit is called as the unit vector and it is denoted by a cap. So the symbol represents cap. So you have to put a cap among any variables, then it represents the unit vector. So when I say b cap, it is a unit vector. So therefore, whose magnitude is 1, that means the length of the vector is 1 unit or it is a unit, then it is called as unit vector. Next, co-initial vectors. 2 or more vectors having the same initial point are called as co-initial vector. So, if I take a point A as an initial point, many vectors can have the same initial point but different terminal points. So, these vectors, so I can write vector A, vector B, vector C, vector D. So, all these vectors are called as co-initial vectors. Next, collinear vectors. 2 or more vectors are said to be collinear if they are parallel to the same line irrespective of their magnitudes. The magnitude irrespective of their magnitude means it depends on their directions also. Suppose I consider a straight line like this, a vector which is parallel to the given line is called as the collinear vectors. So their magnitude may differ, their direction may differ, but magnitude is nothing but the length of the vector. Direction is opposite to the other vectors. So whatever it may be, so whether it is a magnitude or whether it is in terms of direction, it does not mind here. The only thing is it must be parallel to the given line. That is called as the collinear vectors. Next, equal vectors. 2 vectors are said to be equal if they have the same magnitude and direction regardless of the position of their initial point. So their initial point may differ, but their magnitude and direction must be in the same. So that is, if I take a vector AB of 5 centimeter, then the initial point of the other vector may be somewhere, but the direction must be same and whose magnitude must be same. So therefore, here you can see we have 2 vectors AB and CD with 5 centimeter along the same direction. Hence, whenever 2 vectors are said to be equal, that means they have same magnitude and direction regarded to the position of their initial point. So they may go like this also, the direction may differ also, but their magnitude must be same. They may take opposite direction with different initial points, but the thing is their magnitude must be same. Next is negative of a vector. A vector whose magnitude is same as that of given vector, but direction is opposite to that of it is called as negative of the given vector. Suppose I write vector A here, then this is called as minus vector A. Their magnitude is same, but the direction is exactly opposite to it. When I say vector AB, then I can write this as minus BA also. So here vector goes from A to B, and when I say B to A, it is like this. It is exactly opposite to the direction of the vector AB. Their magnitude is same, but their direction is opposite to each other. So next we have the addition of vectors. How to add any 2 vectors. So consider here we have a triangle. So that is triangle ABC. How to add any 2 vectors. Suppose I write a vector AB like this. The initial point of one vector, and when we have terminal point of the same vector, then the other vector must be taken in an order such that the initial point must coincide with the terminal point of the other vector. So when we add these 2, we will get the vector like this. Then what is the value of the vector? So if this is A, this is B, this is C. Okay. So the third side of the triangle represents the sum of the vector. If I say this as vector A, if I say this as vector B, then this is what your vector A plus B. So this is called as the triangle law of vector addition. That is, when you have any two vectors, form it in the way along the side of a triangle, then the third side becomes the sum of the two vector. So this is what the vector law of addition says. Suppose when I change the direction of vector BC here, see clearly this is vector A. When I change the direction of vector BC here, so like this, then the resultant vector here. So this is B and this is C. This is A. So this is vector AB and vector BC, which is equal to vector AC. So this is also vector A plus B. When I change the sign of this, so that vector AB, here BC can be written as minus CB. Change the direction of the vector, then this is nothing but vector A minus vector B. If I change the direction of the vector, this is vector A and this is vector B, then this is vector A minus B. So this is what the vector property says, and this is the triangular law of addition of vectors. Now, clearly see, this is the direction of vector A and this is the direction of vector B. Now this is the direction of vector C. If I change the sign of the third side, that is, if I take a vector from C to A, then what happens? Then vector AB plus BC plus CA will always be a null vector. That is, when you add all the sides of the vectors in this form, that is vector AB in this direction, BC in this direction and CA in this direction, the resultant vector will give you the null vector. So therefore, the sum of any two vector is always the third side of the triangle, which is the triangular law of addition. We have one more law for addition of vectors. So that is the parallelogram law of vector addition. So here, let me take two vectors, vector A and vector B. So according to triangle law of addition, the initial and the terminal side of the other vector has to coincide. So what does the two vectors says here? So let me take here, this is vector AB and this is vector AC. Okay, so then what does parallelogram law of vector addition says? That is, the draw two parallel lines parallel to AC and AB. Then the diagonal represents the sum of the two vectors. So if I say this is vector A and this is vector B, then vector A plus B is the diagonal inside the parallelogram. So this is same as the triangular law of addition. What does the triangle law says? When you have vector A with terminal and initial point coinciding with the other vector, the third side of the triangle represents the sum of the other two vectors. So, and here also diagonal is nothing but the third side of the triangle. Hence, we can clearly say that the triangular law of vector addition as well as the parallelogram law of vector addition are equivalent to each other. Thus, we can add any two vectors in any one of the form, either using triangular law of addition or using the parallelogram law of addition. Now, let's see the properties of vector addition. So, first one, vector A plus vector B is commutative. So, whether you add vector A to vector B or vector B to vector A, it is one and the same. So, therefore, the addition of vector is commutative. Now, let me take two vectors. Vector A, so this is vector A and this is vector B. So, that is the terminal point of the other vector has to coincide with the initial point of the second vector. Then what is the sum of these two vectors? So this one. So this is your vector A plus B. Now this is our terminal point. Let me add one more vector here. Let me take this as vector C. Then what is the sum of these two vectors? This triangle. This is your vector A plus B plus C. Now let me take vector B here and add it to vector C. What is this? This side will give you B plus C. Now let me add vector A here. So then this line will give you A plus B plus C. So clearly you can see the vector addition is associative. So this is associative. So therefore, the associative law of vector addition helps us to write we can add any three vectors. Since whether you add the first two vectors or last two vectors with the first, they are one and the same. And this is equivalent to A plus B plus C. So this is your A plus B plus C. We can add any three vectors in any one of the form. Since it is associative, we can add all the vectors at the same time. So next we will take the identity law for vector addition. We know that vector A, when it is added to the null vector, then or a null vector added to the vector A, the result is same. You will get vector A. So therefore, we can say 0 as the identity. So this is the identity for vector addition. That is vector 0 can be taken as the identity for vector addition. Next we have multiplication of a vector by a scalar. So here I have taken vector A and here we have 2 times vector A. That means the distance of vector A is taken 2 times in the same direction. So this is what? 2A. Suppose I say half of the vector A. If vector A is the distance AB, then half of it, let me take it as AC. This denotes half of vector A. So therefore, the scalar multiplied here gives you the total length of the vector. So therefore, we can take 2A, 3A, NA for any vector. So therefore, any scalar quantity can be multiplied with the vector, but it is clear that it is always parallel to the given vector. When I say half A, so it is half of vector A, but it is exactly parallel to the given vector. When I say 2A, when I say 3A, it is twice or thrice the given vector, but it is a collinear vector with respect to the given line. So here I have taken, so if I take this as a line here, you can see clearly this is A and this is 2A. Look at minus A here. So the direction goes like this here. So minus A means minus 1 into A. Okay. So the length of A is same, but the direction is opposite to it. We can also write minus 2A. Minus 2A represents the opposite vector to the vector 2A. So that's negative indicates the direction is opposite to the given vector. Now in general, we can take the scalar of any vector in the form of lambda into vector A. So where lambda is a scalar quantity. Now as I said, minus A or minus of vector A, this is nothing but the negative of vector A. So this is called as the negative of vector A, or we can also call it as additive inverse. Additive inverse of vector A. Why? Because if I add it to vector A, or if I add negative vector A to the positive vector, then the resultant is always the identity. That is, what is the identity for the vector addition? That is null vector. So when I add the vector and its negative of vector A, then the resultant is always vector 0, which is a null vector or the identity to the vector addition. Also, remember that when you multiply any scalar to vector 0, it is always null vector. Okay, when you multiply any scalar, any value, any numerical value to the null vector, the resultant vector is always the null vector. So these are all the basic concepts which you should know. That is, what are the position vector, what is the magnitude of the position vector, types of vector which they may ask you for 1 marks in your examination, and few components related to vector. We'll meet you in the next session with other components related to vector. Until then, keep watching, keep learning, keep exploring. Thank you.